So today I'm going to be talking you through the formation of the primary haemostatic plug. So this is the initial part of a clot that forms when you have damage to a blood vessel. And I'm going to explain it in 10 simple steps, each building to then show how the clot forms, and then I'll move on to explain how the secondary haemostatic plug forms a larger, more powerful clot. So step 1 involves damage to the endothelial lining of a vessel. So the red line represents the wall of the blood vessel, and then we've poked a hole in it through, it could be a knife or anything that damages a blood vessel. Then our second step involves collagen, which is held within the endothelial lining, becoming exposed, and therefore the blood is able to run past the collagen, and things inside the blood are exposed to this collagen. We then have platelets, which are floating around inside the blood, binding to this collagen, and this takes place at the GP1A receptor of our platelet. This activates our platelet, and that causes granules, which contain thromboxane A2, ADP, serotonin or 5-HT, and von Willebrand factor to be released, and they go and have the effect of causing further coagulation within the vessel and around the site of the damage. We then have the von Willebrand factor that was released from the granules in the previous step and is floating around in the blood, coming and binding to a separate receptor on the platelet, and this is the GP1B receptor. The von Willebrand factor then binds to the wall of the vessel, and this helps to anchor the clot, so it's now bound to the wall of the vessel at both the collagen exposed site with the GP1A receptor and through the von Willebrand factor at its GP1B receptor. The granules, which were released previously in step 4, also go on to recruit platelets and fibrinogen, so they're floating around nearby and they get drawn towards the site of the clot. The fibrinogen binds to the existing platelet at the GP2B3A receptor. Fibrinogen has two separate arms, and this allows it to bind another platelet together at the same site, also at the GP2B3A receptor. This means that now we have a clot, or a platelet, which is bound at the GP1A receptor by collagen to the site of injury, through von Willebrand factor at the GP1B receptor to anchor it to the wall, and is bound to another platelet at the GP2B3A receptor through fibrinogen to increase the size of the clot. This process then repeats over and over and over until you eventually have the formation of larger clots, as other platelets can bind at the other bits of exposed collagen, and the platelets each have multiple GP2B3A receptors, so multiple platelets can bind through other fibrinogen molecules. So our 10 simple steps are: 1. Damage to the endothelial lining of the vessel. 2. Collagen within the endothelial lining is exposed. 3. The platelet at the GP1A receptor binds to the exposed collagen. 4. Granules containing thromboxane A2, ADP, and von Willebrand factor are released. 5. Von Willebrand factor binds to the GP1B receptor on the platelet. 6. The von Willebrand factor anchors the platelet by binding to the endothelial wall. 7. The released granules recruit platelets and fibrinogen. 8. Fibrinogen binds to platelet at the GP2B3A receptor. 9. The fibrinogen binds to a second platelet, binding these two platelets together. And 10. Further platelets build upon this clot, forming a primary haemostatic plug. So, this diagram here shows how some of these processes work for those who like to have a more full image of how on a molecular level this works, but you don't need to know it in anywhere near this detail. You need to know it in about this detail. So as you can see here, we have our damaged vascular endothelium with exposed collagen binding at GP1A, GP1B and von Willebrand factor, anchoring it to the wall, the release of granules which cause further coagulation, and fibrinogen binding platelets together at the GP2B3A receptor. So we also have some drugs which affect the platelets and how effectively they work. So the first of these is aspirin, which is a non-steroidal anti-inflammatory drug. So its mechanism of action is COX inhibition in the arachidonic acid pathway, and this prevents the formation of prostaglandins. And in platelets, this prevents the formation of thromboxane A2, which causes further coagulation. So it essentially stops the activation of further platelets after your initial binding. And clopidogrel acts in a similar way, except it stops ADP from binding to platelets, and ADP binding helps to activate the platelet further, causing the release of more granules, which causes further clotting again. So essentially all you need to know about the formation of a platelet is you have vascular endothelium, which is damaged with exposed collagen. The platelet binds at the GP1A receptor, which then also has von Willebrand factor binding at the GP1B receptor and anchoring to the vascular endothelium. You then have the release of granules, thromboxane A2, 5-HT, ADP, and von Willebrand factor. And you then have fibrinogen binding together two platelets at the GP2B3A receptor. Aspirin acts on the coagulation by preventing the formation of thromboxane A2, which is one of your molecules causing further coagulation, and clopidogrel prevents the binding of ADP, which also causes further coagulation. And that is essentially the primary hemostatic plug.